波がすごい勢いで押し寄せてきます。時間は今午後3時21分頃です。すごいです。
On March 11, 2011, an earthquake measuring 9 on the Richter scale occurred in the Sea of Japan, triggering a massive tsunami. The Fukushima nuclear power plant, which has been in service for 40 years, suffered a devastating blow, with multiple reactor cores melting and causing a hydrogen explosion. After the situation was back to control, polluted groundwater and cooling water were accumulated and stored in over 1,000 large tanks. On August 24, 2023, Japan started releasing the treated wastewater into the sea. It is estimated to take 30 years to complete. The nuclear wastewater is first treated by ALPS, further diluted, and finally discharged into the ocean in batches. The wastewater contains 64 radioactive elements before treatment, and ALPS can remove 62 of them. Only tritium, an isotope of hydrogen, and carbon-14, an isotope of carbon, cannot be removed. Prior to discharge, the concentration of carbon-14 in the wastewater has reached the acceptable standard according to TEPCO in Japan, and it is further diluted by 40 times before discharge into the sea. Carbon-14 is considered as a less radioactive and harmful element, although some scholars believe that its harm to organisms has not yet been fully studied. Tritium emits beta radiation and is medium radioactive, but much weaker than X-rays and gamma rays. U.S. Environmental Protection Agency, USEPA, explains the dangers of beta radiation on its website as follows. Beta particles, beta, are small, fast-moving particles with a negative electrical charge that are emitted from an atom's nucleus during radioactive decay. These particles are emitted by certain unstable atoms such as hydrogen-3, tritium, carbon-14 and strontium-90. Beta particles are more penetrating than alpha particles, but are less damaging to living tissue and DNA because the ionizations they produce are more widely spaced. They travel farther in air than alpha particles, but can be stopped by a layer of clothing or by a thin layer of a substance such as aluminum. Some beta particles are capable of penetrating the skin and causing damage such as skin burns. However, as with alpha emitters, beta emitters are most hazardous when they are inhaled or swallowed. It can be seen that the potential harm caused by tritium in seawater will mainly come from diet, mostly seafood. The Japanese government and the International Atomic Energy Agency confirmed that ALPS cannot remove tritium from nuclear wastewater. A report on IAEA's website states that tritium has properties similar to hydrogen in water, making it difficult to effectively remove from water. IAEA is responsible for regulating the application of atomic energy and is headquartered in Vienna, Austria. The agency is certainly familiar with methods and standards for handling radioactive materials in nuclear wastewater. Future technology will be able to eliminate tritium and carbon-14 in nuclear wastewater, but this is probably not the key factor in deciding on the wastewater release plan, which will be revisited later. Since ALPS cannot eliminate tritium and carbon-14, the Japanese government's final decision is to dilute it before discharging it and ensure that the concentration of tritium and carbon-14 in the discharged wastewater is far lower than international and Japanese drinking water standards. IAEA validated the safety by their reports. TEPCO reported that in the water samples collected on the first day of the discharge, 1,500 becquerels units of tritium per liter of water were detected, while the drinking water guideline published by WHO requires tritium to be less than 10,000 becquerels per liter. This doesn't sound too bad. Radioactive elements will decay due to radiation, and tritium will decay into helium-3. Tritium has a half-life of 12.3 years. Every 12 years or so, the amount of tritium emissions halves. Therefore, a simple idea is to store it for another 12 to 24 years, then the radioactivity will be halved and further halved. The question is that better than dilution and discharge? After all, these radioactive elements are also present in normal seawater and freshwater, although the concentration of tritium in common tap water for drinking can be 1 becquerel per liter. Based on the analysis, people living around the Sea of Japan do not need to panic excessively, and there is no need to rush to buy iodized salt or hoard seafood. However, this does not mean that everything will be fine from now on. Just think for a moment, did the international community or governments always prioritize environmental protection so that people on the planet can live and work in peace and contentment? If it is true, I don't think people in and around Japan will protest loudly and angrily against this nuclear wastewater release, right? Let's use a little imagination. If the diluted wastewater was distilled and bottled, how many people would be willing to drink it? Even when they are very thirsty, most people will not choose to drink to quench their thirst. I am afraid they will only consider it when running out of drinking water in a desert, right? Regarding the drinking water standards of tritium, in fact, countries come up with different numbers, and they can be different among states or provinces in North America. As aforementioned, the tritium in Fukushima nuclear wastewater was diluted to 1/40th of the Japanese standard, and it is 1,500 becquerels per liter. According to TEPCO, it is further diluted into the background level in the sea within 2 kilometers of the outlet, approximately 100 becquerels per liter. The famous scientific magazine Nature published an article in June this year, specifically mentioning that scientific researchers from some professional institutions are opposed to the issue of whether it is safe to discharge Fukushima nuclear wastewater into the sea. The National Marine Laboratory Association of the United States disagrees with Japan's plan to release the wastewater into the sea in 2022, believing that its safety lacks sufficient scientific data support. Robert Richmond, a marine biologist at the University of Hawaii, also thinks that the plan fails to prove that the treated nuclear wastewater is not harmful to marine life and human health. Richmond, one of 5 scientific advisors to the Pacific Islands Forum, a cooperative forum of 18 Pacific Island countries, believes that the impact of tritium and carbon-14 on the marine environment has not been clearly investigated. Shigeyoshi Otasaka, an oceanographer and marine chemist at the University of Tokyo, also said that organically bound forms of tritium may gradually accumulate in fish and other marine organisms, referring to a term called bioconcentration in the food chain. As the food chain goes up, toxic chemicals in living organisms accumulate over time. Their tissues or chromosomes may be damaged or mutated as a result. Humans are at the top of the food chain, which could lead to higher chances of cancer and other diseases. The article mentioned a key point at the end: discharging nuclear wastewater into the sea is actually a routine for nuclear power plants in various countries, and it is a normal design and operation as of today. Many nuclear power plants are built near the coastline to facilitate the use of seawater to cool down reactors, and then treat and dilute the wastewater before discharging it back to the sea. Japan and the UK are examples mentioned, but other countries do so as well. This seems to be the key factor for the IAEA and relevant countries to approve Japan's plan. The international experts convened to discuss the plan a few years ago. According to the declaration from IAEA, the atomic watchdog of the UN, Japan's plan was consistent with the international safety standard. Broadly speaking, nuclear reactors around the world, including nuclear bomb tests, nuclear-powered aircraft carriers, nuclear submarines, etc., may release or leak radioactive wastes or wastewater. The polluted natural resources may be water, air, or soil. Another reason that governments and their organizations are reluctant to mention may be that during and after the Fukushima tsunami, seawater completely soaked melted reactor cores and discarded fuel rods, and a large quantity of radioactive contaminants already entered the seawater in an uncontrolled manner and spread out to the oceans over the next 12 years. This part of the polluted water contains 62 radioactive elements that were later filtered out by ALPS, including isotopes of strontium, cesium, and iodine that are more dangerous to the human body. Hence, somebody says that adding a small amount of tritium and carbon-14 to the oceans may not be much worse than the situation then. A few years ago, there were videos showing American residents used radiometers to measure radiation levels on California beaches and recorded significantly elevated numbers. The FDA in the US also issued an import alert to warn not to import and eat certain Japanese products around Fukushima that might be contaminated. The import alert was not lifted until September 2021, 10 years after the tsunami. Due to the social impact of the Fukushima nuclear pollution disaster, the international community has shut down many nuclear power plants in the past 12 years. The New York Times reported that New York State completely shut down the Indian Point nuclear power plant at the end of April 2021. The power plant had been in service for 59 years. After the shutdown, the nuclear power plant was acquired and handled by a private company for the cleanup of nuclear waste or wastewater. In April this year, New York State suspended the idea of expediting the release of wastewater into the Hudson River. The wastewater was filtered after cooling the spent fuel rods, according to the news report. The Hudson River enters the sea beside New York, 30 miles downstream. The website of China Nuclear Power Grid published a news commentary on the shutdown of the Indian Point power plant in 2021. The commentary was generally balanced and objective. The nuclear power plant was said to provide as much as 25% of New York City's electricity. After the shutdown, New York plans to gradually turn to wind and solar power as alternative energy sources. However, that may take years to accomplish, so New York built 2 natural gas-fired power stations in the town, and the employment opportunities lost could also be provided there. However, from the environmental impact perspective, fuel-burning power stations will pollute the air and increase carbon emissions, and the price of natural gas is also much higher now than before. Meanwhile, the cleanup of the power plant is a hot potato. In mid-April this year, Germany completely shut down all nuclear power plants. European countries such as Spain, Switzerland and Belgium also plan to phase out nuclear power plants. Italy shut down all its nuclear power plants as early as 1990 and has not restarted them ever since. The United States once reached its peak nuclear power output with a maximum of 104 reactors in operation in 2012. The number had dropped to 93 by 2022. Currently, 32 countries and regions around the world are operating nuclear power plants, and several countries are still under construction. According to a report released by the IAEA, there are approximately 400 nuclear power reactors in operation around the world, and about 57 are also under construction. The 10 countries with the largest number of operational nuclear reactors are the United States, 93, France, 56, China, 55, Russia, 37, South Korea, 25, Canada, 19, India, 19, and Ukraine, 15, Japan, 10, and the United Kingdom, 9. Japan temporarily shut down all nuclear power plants after Fukushima disaster.
We have wonderful news to report from Japan. Citizens were able, through the courts, to stop an operating nuclear power plant. These are citizens living between 30 and 70 kilometers away from the Takahama nuclear power plant. It was operating, and the injunction lawsuit says you have to shut it down, and the next day the utility had to shut it down.
In the past 2 or 3 years, Japan, under power supply shortages, has restarted 10 of its 33 existing reactors, 7 more have been approved to restart, 8 more are applying for restart, and 2 more are under new construction. 10 years after the Fukushima nuclear accident, Japan is in the middle of restarting most of its nuclear energy businesses. There are also 3 reactors operating in Taiwan, but not shown in the table. Currently, the countries with the most reactors under construction are China, 21, India, 8, Turkey, 4, Egypt, 3, South Korea, 3, and Russia, 3. China will soon surpass France in the number of operating reactors, but the United States will still be far ahead of the rest for years to come. In addition, nuclear power in the United States currently accounts for 18% of the country's total electricity consumption, France accounts for 63%, and China only accounts for 5%. From the Wayno.info website, you can check the location distribution of nuclear power plants in various countries on the map. In addition, the websites of government agencies in many countries also provide detailed information on civilian nuclear energy, nuclear facilities, waste treatment, medical use, scientific research, industrial applications, etc. For example, on the Canadian government website, www.nuclearsafety.gc.ca, you can check the government registration management of various nuclear applications. Canada's 5 nuclear power plants are located in the eastern provinces of Ontario, Quebec, and Nova Scotia. From these maps, we can see that nuclear power plants are mostly built in places with sufficient water sources, especially near the seas. A relatively small number of them are also built near inland rivers and lakes. Nuclear power plants require a large amount of cooling water to maintain the stable operation of the nuclear reactors and also facilitate the treatment and discharge of the wastewater. If conditions permit, it seems to be a reasonable design to build a nuclear power plant on the seaside some distance away from a big city. Looking at it this way, we can understand why Japan insists on discharging Fukushima nuclear wastewater despite the strong opposition. It is more or less a routine operation if only tritium or carbon-14 are involved. Some people say the wastewater did not remove 62 radioactive elements except tritium and carbon-14. That could be unsure, but there is no strong evidence to prove. From the perspective of the psychological impact on the layman of nuclear businesses, one could feel that the international handling of this nuclear leak accident lifted the fig leaf for various radioactive emissions, or perhaps just a corner of it. Natural disasters are terrible, but man-made disasters are chilling. According to information on the internet, the state with the most nuclear power plants in the United States is Illinois, where Chicago is located, with 6 nuclear power plants. New York State still has 3 nuclear power plants in operation today. There are currently only 2 nuclear power plants on the west coast of the United States, one in California and the other in Washington. Near the small town of Richland in southeastern Washington state, there is an abandoned nuclear facility that is open to the public and allowed to tour with guides. It is called the Hanford Site. It is designated as a National Historic Monument because it is the site of the earliest large-scale nuclear reactor in the United States. During World War II, it was one of the 3 secret military operations of the Manhattan Project, which provided materials for nuclear experiments and atomic bombs at that time. The nuclear waste generated at Hanford was stored in large metal tanks. Later, the bottom of the tanks leaked, contaminating the soil, and even began to seep into the adjacent Columbia River under the action of rainwater and groundwater, according to some news reports earlier for the public. The environmental pollution problem in this place has not yet found a perfect solution, and it is still in the process of protracted cleanup. Fortunately, the local landform and ecology are similar to a desert of the Midwest, far away from the dense living areas of people and animals. However, if proper treatment is not taken fast enough, the environmental consequences on the river will be concerning. Not far from the old Hanford site, the Columbia Nuclear Power Plant was later built, which has supplied power since the end of 1984. Surprisingly, a piece of technology news in July this year reported that the government planned to build 12 more nuclear power reactors at the same location. These are said to be a new generation of nuclear power reactors that are smaller and cheaper to operate. Hope these new reactors are also safer and more environmentally friendly. It seems that before safe, radiation-free, and controllable nuclear fusion technology is successfully developed, nuclear fission technology will continue to produce a large amount of wastewater because society wants to get clean energy with low carbon emissions to protect the atmosphere. After all, for individuals and companies, power outages are unbearable to live with, and the choices at scale are limited for some countries. There is an interesting episode here. In the lower left corner of the 2 old and new nuclear facilities marked on the map of Washington state is the LIGO Scientific Observatory. One of the gravitational wave observatories that caused a sensation several years ago is located here. The application of Einstein's mass-energy equation to atomic energy and the observation of gravitational waves predicted by the general theory of relativity came across here. North of the port city of Marseille in southern France, the International Thermonuclear Experimental Reactor, ITER, is also busy integrating and assembling the world's largest tokamak nuclear fusion device. This large-scale international cooperation project was launched in 1985 and lasted for nearly 40 years. The primary goal was to prove the feasibility of nuclear fusion power generation. 35 countries and regions have participated in cooperation and construction, and there are currently 7 main members: China, EU, India, Japan, South Korea, Russia, and the United States. Most countries and regions that use nuclear fission technology to generate electricity have participated in this cooperation project or are interested in further cooperation. It is widely hoped that this international major project can solve some of the toughest engineering problems for nuclear fusion technology and ignite a safe and powerful man-made sun. Human beings have thrived on the Earth for generations, and the ocean is the largest and most important natural resource of this blue planet. The oceans gave birth to the first lives, while rivers and lakes nourished great civilizations. In this vast universe, the Earth's clean water and air, as well as suitable sunlight and temperature, create a rare and precious living space for animals, plants, and humans to coexist. With the rapid development of science and technology, technology has become more and more like a sharp double-edged sword. The outrageous release of Fukushima nuclear wastewater reminds us once again that technology can protect the environment or damage it. Everyone has a share of responsibility to protect it.